The first topic we cover in the automated chapter of Well Architected is business process optimization. And there's a reason why it's first. You see, all of the topics and subtopics in the framework are arranged in priority order. So process optimization comes first in automated because you should never build an automation without an optimized business process. And I'm sure that makes sense when you read it on paper. You've probably even heard it before, but you may also be wondering, what does an optimized business process really look like? Well, let me tell you a story that's going to illustrate that. I used to work for a company that made cell phone towers and antennas. And one of the things I had to do when I worked there was design an application that would help our sales reps walk through a tower design with their customers and figure out how much it was going to cost. This sounds easy, but it's actually a lot more complex than you might think. Now, I'm not going to go into all of the math that's involved, but there are a lot of complex calculations that I have to do with building a tower. So you need to know the height of the tower, you need to know what the environmental conditions around it are, and if you design it wrong, you could end up building a tower that's too light, that's going to come crashing down on a highway, which is obviously bad. Or you can design a tower that's going to be too heavy, in which case you're going to end up building something that's too expensive, and your competitors are going to undercut you on the price. So we needed to find that sweet spot in the middle where we were building a tower that would handle the load that needed to be put on it, but without costing our customers too much money. And something that we found out was that there's a lot of math that goes into this, but all of our engineers were doing the calculations in different orders. They were coming up with different results. They were arguing over the results, and there was no real standard way of doing this. So I worked with one of our senior engineers who did an extensive analysis of all of the towers that we had built. And between the two of us, we were able to derive a specific set of equations and process steps that would produce consistent results to design a tower and come up with an accurate cost that our customers were really happy with. Let me show you what that process looked like. The first thing we needed to do was find out how high the tower needed to be. And this is a customer requirement because it can affect the signal that's being broadcast because the antennas need to be higher than any obstructions that might be in the way, like buildings or mountains. So we had to get that input first. The next thing we had to do was get the height above sea level because that can affect the overall height of the tower. So that was our second input. Our third input was the terrain type. So different types of terrain can support different weights and different styles of towers. And if you're building a tower on something where there's already concrete, for example, you're going to build a different type of tower than one that you're building on sand or peat moss or something that's going to be really squishy. So we needed to keep that in mind as well. So that was our third input. The next thing we had to do was find out the average wind speed in the area. And that's usually in a range of low to high. And we needed to make sure that the amount of wind that was going to be blowing on the tower both consistently and when there was a big gust, that the tower would be strong enough to handle that. But what we had to do, it wasn't just the tower that had to handle the wind speed. It was whatever we were putting on it, because antennas are shaped like bowls and they act like giant catcher's mitts that can actually absorb wind and create additional force. So once we had the average wind speed in the area, the next input we got was the height and the size and dimensions of the antennas that were being put on the tower. Now once we had those things, we had enough information to do our calculations. And when we did that, we were able to calculate the force that the tower needed to handle. We were able to calculate the amount of steel that we needed that would be able to handle that amount of force. And then from the steel, we could get the price of the steel and we could get our final output, which was the actual cost of the tower. Okay, so obviously there are more details than that as far as the specific math formulas go and how things are calculated. But at a high level, that's what the process looked like. And that's enough information to take a step back and look at the characteristics of that process. So it has a clear purpose, which is to determine the cost of a tower. It has clear inputs. So we had the tower height, the height above sea level, the terrain type, the wind speed, and the antennas that needed to go on the tower. And it also has a clear set of steps. So we collected all of those inputs in order, and then we did all the calculations in a specific order to arrive at the amount of steel we needed and the cost of the tower, which is our measurable output. So that is what a well-architected process looks like. And I'm happy to say that after we released our application, our tower sales increased exponentially. And that's because we had an optimized process that was helping our own engineering team produce more consistent results that were making our customers happy. But also, our competitors didn't have anything like this. They were still doing things the old way, where every engineer just kind of figured things out on their own, and engineers would argue it would take longer to design a tower because nobody could agree on anything. Whereas we had a consistent set of steps that we were following and an optimized automated business process. So this is an example of why you need to make sure that your processes are optimized before you actually build the automations that are associated with them. You can read more about this in Salesforce Well Architected Automated. I put the link in the description below, so make sure to check that out. And also make sure to like and subscribe if you found this video to be helpful. I'm looking forward to seeing you next time.